Hey, this is chapter 12.2. We're going to be analyzing arithmetic sequences and series. So in an arithmetic sequence, we have a common difference, or D. So a series, for example, could be 2, 5, 8, 11, in which our common difference is 3. So between each number, we have 3. When we write this out in a formula, we have a sub n equals a sub 1 plus n minus 1 times d, in which a sub 1 is our first term and d again is our common difference. So we're told to write a rule for the nth term and then find a sub 15 for this series. So first we can identify that 4 is our first term, and therefore a sub 1 equals 4. Next, we identify that there are 5 numbers in between each of these, so d is 5. D is our common difference, so difference between 9 and 5, 9 and 4 is 5, 14 and 9 is 5, and 19 and 14 is 5. So we can plug this into our formula. We have a sub n equals 4 plus n minus 1 times 5. Simplify this to negative 1 plus 5n. So we've solved the first part of this problem, in which we're writing a rule for the nth term. Next, we need to find a sub 15. So a sub 15 equals negative 1 plus 5 times 15. Simplify this and we get 74. Next, we're going to write a rule given two terms. Our two terms are a sub 8 equals 21, so we have our 8th term. And next we have a sub 27, or our 27th term, which is 97. So first we're going to write a system of equations using a sub 1 equals, a sub n equals a sub 1 plus n minus 1 times d. Next, we're going to substitute 27 for n into this, and also 8 for n. So our first equation will be 97 equals a sub 1 plus 26d. Our second will be 21 equals a sub 1 plus 70. Next, we're going to solve this system. So we have 76 equals 19d. Solve for d, which is 4. Next, we're going to plug this into our equation of a sub n equals a sub 1 plus n minus 1 times d, plugging in values for a sub n and d. Plugging in values for a sub 1 and d. So a sub n equals negative 7 plus n minus 1 times 4. So a sub n equals negative 11 plus 4n. The final part of this section is the sum of an arithmetic series. So the formula for this is s sub n, with s being our sum, equals n times a sub 1 plus a sub n over 2. So we're told to find the sum of this series. Our first step is to identify what a sub 1 is. So a sub 1 is 3 plus 5 times 1, because our index is 1, which is 8. Next, we need to find what a sub 20 is. So 3 plus 5 times 20, which is 103. Now we can finally plug this into our sum formula. And simplifying this gives us the answer of 1110.